Hello, everyone. You are welcome to today's lesson. And in today's lesson, we are going to continue from lesson 2 of on the topic SURDS. Okay, and we are restricting ourselves to core math SURDS. Okay, all right. So in lesson 1 and 2, okay, we looked at the algebra of what? Of SURD. Lesson 1, we concentrated on addition and subtraction. Lesson 2, okay, we dwell so much on multiplication. So we looked at the various forms apart from the roots of multiplication. Okay, and we're also supposed to look at what? Division. But time didn't allow us to do the division. We'll continue with the multiplication. Now we know the multiplication rule, we know the division rule. We've not made use of the division rule yet. Very soon, I mean, today we'll do that. Okay, however, we encountered various situations, various questions that, okay, required us to make use of what the rules and the multiplication. Today, we are going to continue from where we left off. We'll continue with more questions on, okay, the multiplication of what SURDS. Okay, especially when you have special situation, how best to simplify using your rules. Okay, so quickly, let's go and have, I think we ended here. We did this one, and the advice was anytime any expression, okay, is given an SURDic expression for that matter, and you are asked to simplify. First of all, check, okay, if any SURD that you have there, you can reduce, meaning if it's not in its basic form, reduce before you even start multiplying. And by so doing, you avoid working with what? Big values. Okay, and that was one of the major advice that you were giving, okay, yesterday. So we are going to continue. Okay, this one, we are not going to touch it. Okay, equally, this one you try, but I'll just give you a hint. You know how to expand this. Okay, you know how to expand this. We have two ways of dealing with this. Okay, but okay, let's do that together and see. Going forward, you encounter a situation which will require the use of this. So this is what we are going to do. Solution to question 4, we did A. So question, let me see where we ended. Whether we did, okay, I remember we did the A. Okay, we are going to do the B and maybe the D together. Okay, so I'm not going to skip. So let's continue with the B here. Okay, B, what are we giving? We are giving, okay, root of 2 into, okay, 2 root of 2, okay, then plus root of 6, but that's not all, minus 2 root of 3. Okay, I guided you, I remember yesterday, I guided you as to how to deal with it. But let's have, okay, the clear picture. So there's an expression, you start introducing your steps with equal to. Here, fortunately for us, okay, none of the SURDic terms here, okay, it's not in its basic form. All of them are in their basic form, so we can't reduce any of them. So in that case, it means we move on to the expansion. First of all, you check whether the terms in brackets you can further simplify. If by either combining, I mean adding, subtracting, what have you. If not, then you come and remove the bracket. So when you remove the bracket, we are going to get, okay, 2 into root of 2 squared. Do you agree? Someone can also write 2 into root of 4, 2 root of 4. It is allowed. It's the same thing. Okay, then plus, okay, I just want to be consistent based on how we've been presenting our solution. Okay, so this one will give us root of 12. Do you agree? That is this one times this. I'm doing this one times this. This one times this is what I have here. Then this one, please take note. This is not multiplying it. This is a term on its own, so we just come and add it or attach it. Is that clear? Hello, yes. My profs, are you there? Good, all right. So now at this point, we have this bracket to remove. So we are going to have 2 root of 2 squared, we all know will give us what? 2. Okay, Prof. Refua. Prof. Refua, your hand is up. Or it's a mistake. Please unmute.
Yes, please. My question. Yes, please. My question is that. Oh, please. My question is that the first And why is it that we didn't put the 2 root 2 squared plus root of 12 in a bracket?
Okay, so you know,
Since
are you
in
talking
the
about this
question
one?
it was
Are you talking about this one?
yes,
Or
please.
this?
The second step.
This is the first step. This is not a step.
Yeah.
Your step starts with the equal to. So this is how you count your step. First step.
Yes, please.
Okay. What was your intention? You were removing bracket. Is that not it?
Yes, please.
So it will be this one times that, which will give us this. Then this one times also this, which will give us this. We are removing the original bracket. That's the intention. Is that clear?
Okay, yes, please. Thank
You
you.
get it now. You are welcome. Okay. So it's good to ask questions so that you demystify or concern. So in this case, this gives us the then plus, okay, root of 12, you know it's not in basic form. So this one we have to reduce. So we are going to have root of what? It will be what? 4 times 3, is that not it? Then minus what? 2 root of what? Root of 3. Okay, at this point we know we are going to get, this will give us 4, then plus, this will give us 2 root of 3, then minus what? 2 root of 3. Is that clear? Okay, so in effect, we will know that this will come and cancel this because these two are like terms. When you combine them, it will give you 0. So you'll be left with only the 4. So you go, and you know that that step you land at your answer. So you go and have your conclusion drawn there. So therefore, root of 2 into what? 2 root 2. Okay, then plus root of 6. Okay, minus what? 2 root 3 will be equal to 4. All correct?
Yes.
Okay, so very good. So, okay, today we are going to look at what we have in red. Usually it will be for you, but don't worry. Let's do that. Going forward, we will need it. So D, what do we have? We've been given, or like I said, you can choose not to write the given. So just extract what you have there, which is 2 root of what? 5. Okay, squared. Okay, minus 3 root of 7, also squared. Okay, so we know we did a situation where you have only one, okay, squared. Now it is 2. The subtraction is the same thing. You know how to deal with 1. So you should know how to deal with a number of them. So this will give you 4 because it will be 2 squared, which will give us 4. Then into root of 5 squared, okay, which we can write 5. Okay, then minus, okay, 3 root of u. Let me deal with it the way I have advised you to deal with it. As you mature, okay, I will tell you this and that, don't do it. Okay, so let me do the needful. Okay, Prof. Paulette.
Sir, please, can you also do it in difference of 2 squares?
You want to take the wind out of my sail, I won't mind you. All right. Okay, we'll look at it from the alternative perspective, then we'll draw the conclusion together. Is that clear?
Yes, please.
Okay, so we'll do that and see whether you can do it, but is it prudent for you to do that? Okay, very soon. So let's go our normal approach. So that will give us, let's go. So that will give us 4 root of 5 squared, okay, minus what? 3 squared, which is 9, into root of 7 squared. Okay, as you mature, you can write the 5 and the 7 here straight away. So that gives us what? 4 into 5 minus what? 9 into 7. Okay, which in effect will give us 20 minus what? Hey, my professors, I want you to be active, so let's participate in giving me answers.
63.
Okay, so come again.
63.
Okay, so 63. So the next step will land you at your answer so we can have our conclusion drawn there. So we are going to get therefore 2 root of 5, okay, squared minus what? 3 root of 7, okay, squared will be equal to 20 minus 63, and that will give us, okay, minus 43. Am I right? Okay, so this becomes the answer. Now let's look at what the alternative approach and see whether it will be useful so that out of experience we can make a decision. Okay, so again, what are we given? We've been given 2 roots of 5, okay, squared, okay, minus, okay, 3 roots of 7, okay, squared. And we can see difference of 2 squares here. So this now becomes, okay, this one plus this one in one bracket. So I'm going to write it. This is 2 roots of 5, okay, plus 3 roots of 7 in one bracket. Then in another bracket, what do we have? We will have 2 roots of 5 minus 3 roots of 7. Please, do you agree?
Yes, please.
Difference of 2 squares. A squared minus B squared will give us A plus B in one bracket, A minus B in another bracket. Okay, so at this point, what do you do? Okay, you can see that you are supposed to go and expand term by term. Is my point well made?
Yes,
okay,
please.
which obviously you will know it will involve, okay, more work from here. You get the point?
Yes.
So the purpose is to remove brackets. Immediately you take it to difference of 2 squares. Then what are you doing? You are going to introduce brackets. Is that not it?
Yes, please.
So that should inform you that that is not the right route to go. Okay, so this will be the best approach. Okay, however, okay, now this takes us to our next set of questions. Okay, so any question before we move on to the next set of questions? Are we all on board? Is everyone on board?
Yes, please.
Okay,
the B. Please, the B.
The B.
Yes,
The B has done what? You want me to go over the B?
Yes, please.
Did you just join?
Please, something like that.
Okay, if it's something like that, then you have to wait for something like that in the video to watch. Okay, you can't go by, it will be too far, you know. Okay, let's be fair to each other. Is that okay? So the video will be available, then you go through it. Okay, other than that, someone can come at the tail end and tell, let's start from the beginning. All right. Okay, so I don't encourage. So next time, please, it pays to be, okay, punctual. Okay, so let's move on. I'm sorry, I can't go back. Okay, so let's move on, okay, to our next set of questions. So this is what we have. Okay, work example number 5. Okay, simplify the following. Okay, so we are going to look at it from, okay, for the first one, we'll look at it from 2 perspectives. Okay, then we'll draw our conclusion as to which method will be, okay, ideal. Then the rest will restore to that particular method. Okay, so quickly, let's go and look at what the solution to question 5. So simplify the following. You read the question and underline salient part, if any. There is no salient part to underline. Okay, so you come and write solution, then you write your question number. Okay, then you go to your major question number 5, your minor question number A. So A, what are we giving? Root of 3 minus 1 in one bracket. Then in another bracket, root of 3, okay, plus what? 1. So we know how to multiply binomials. Okay, how to multiply. So we are going to go our usual route, which will be take this one, distribute. Okay, I mean multiply this one by all that we have there. Come and take this one also, then distribute or multiply. So we are going to go our usual way. Remember where we came from, how to multiply 2 binomials. Okay, so now what do we do? This will be equal to, okay, to be root of 3 times root of 3. So that will give us root of 3 squared. Is that clear? Then root of 3 times 1, that will give us, okay, plus root of 3. Minus 1 times root of 3 will give us minus root of 3. Minus 1 times 1 will give us minus 1. All correct?
Yes, please.
Great. Okay, so now we have this to deal with. So we are going to have this 1 squared we know will give us 3. Minus root 3, sorry, plus root 3 minus root 3, that will go. So it in effect, it means I'll be left with only the minus 1 there. So now this will give me positive 2, and that will be my answer. So at that point, I know now we are experts, okay, in knowing where to draw our conclusion to avoid repetition. Okay, so therefore this will be equal to, okay, what you were giving will be equal to what you come and subtract, and that gives you 2. All correct?
Yes, please.
Okay,
Yes, please.
that is one way. Okay, now let's look at the alternative approach. Okay, the alternative approach, what are we dealing with? We are dealing with, okay, so again, alternative approach to question A. Once it's under question, even if I don't write it, you should know. Okay, root of 3, okay, minus 1 in one bracket, into another bracket, root of 3 plus 1. Okay, this is what we have. And just as somebody was able to recognize, okay, that situation that it was supposed to be difference of 2 squares, you should also know this. So with this one, the intention, anytime you are asked to simplify and you have brackets, the intention, the number one intention is to remove brackets. So you know that anytime you have 2 binomials multiplying, don't be in a hurry. That's my advice. Humble one for that matter. Okay, don't be in a hurry to go your usual route, meaning you go and distribute. Check whether the binomials that you are multiplying are special. And how do you identify that your binomials are special? This is what you do. Check whether the binomials, they have the same first terms. Okay, and they have the same second terms. So same first term, you can see. First term here, root of 3. First term here, root of 3. Second term here is 1. Second term here is 1. The sign in between them, okay, is what's not the same. Okay, if the signs are the same, it's still special, and it will give you this 1 squared. So you go back to how to expand a binomial square. So it becomes special. And if the signs are not the same, they are opposite, then you should know that when you expand, you get difference of 2 squares. So don't go and distribute, stress yourself to distribute, because you should be able to recognize this, that if I expand this, I will get what? Difference of 2 squares. So on that note, this is what I'm going to do. I know that, okay, this will give me my first term, which is root of 3 squared. Okay, then minus my other quantity, which is 1 squared. So this in effect will give me 3 minus 1, which I know my conclusion will come here. Root of 3 minus 1 into, okay, root of 3 plus 1 will be equal to 2. Is my point well made?
Yes, please.
How
Yes,
many
please.
steps here? 2 steps in each of them, is that not it?
Yes, please.
However, you can see from the, you know that this step here is the same as this step. Okay, the other step here, this one and this one, obviously you see that this one you write more compared to this. Is that clear?
Yes, please.
Okay, so Prof. Rosemond.
Sir, please, can you come again?
Okay, from where?
The first step.
First step. Okay, all right. Rosemond, you allowed me to finish, okay, solving it before drawing my attention. Okay, so let me see. Another person's hand is up. Maybe I will say, okay, Prof. Inshira, see if I can combine the two in my explanation. Prof. Inshira, was it a mistake?
Yes, it was a mistake.
Okay, all right, okay. Maybe the spirit wants you to ask questions or ask. All right, next time. Okay, don't see that to be a mistake. Okay, so this is it. You should know this, that if you have A, okay, plus B into A minus B, okay, this will always expand and give you difference of 2 squares. This is the factorization of this. And this, okay, what you have here is the expansion of this. Is that clear?
Yes, please.
Okay, so it's that concept that we use. This then becomes our A. This then becomes our B. So if I expand it, just as I say, you can see that it's not necessary for you to see with this one, the minus comes first. This one is the plus. Okay, multiplication is commutative. It doesn't really matter the oppositions. Is that clear? So what you have here is the same as this. So we can apply that principle. Difference of 2 squares. I said, how do you identify that? Same first term, same second term, difference in sign. So those of you who understand, you can move on, okay? If you think we are, okay, wasting, so please move on. You know the rule. Okay, that's why the questions are here. Okay, so that when we solve it, you can compare and see if you got it right, you pat yourself at the back. All right, so now what do we have? We are saying that same first term, same second terms, difference in sign. So that's a special one. which when you expand, you get difference of 2 squares. However, if maybe you were given this just, okay, by the way. So those of you still writing, you can, okay, hold on and get this because I haven't said it. Okay, I said it, but I didn't write it to jump on my point. So assuming maybe it was A, okay, plus B, multiplying A plus B. Okay, I know some of you would distribute, but you should also know that A plus B multiplying itself is the same as what? A plus B squared, is that not it? So this takes us to what we did yesterday, which will be this 1 squared, okay, plus twice the product of this and this, then plus B squared. So that is also a special, that's why I said we have 2 special binomials multiplying. When you realize that they have the same first term, same second term, then same sign, is special. So you can use the expansion, special expansion identity for the binomial squared, which we said this will give us A squared. Okay, where is my? So this will give us A squared plus 2AB plus B squared. Remember what we did in lesson 2, okay, yesterday. Then if you have same first term, same second term, but difference in sign, okay, then you should know that again, you are dealing with what a special one. But once you have difference in sign, automatically that special expansion will be difference of 2 squares. All correct now?
Yes, please.
Okay, great. All right. Okay, so now we are going to do more. We have a lot here. Maybe we are going to look at B. I will skip maybe look at what D. Okay, sorry, E. Then the rest, I believe you should be able to deal with it. So now let's go B. Okay, what are we giving? We are giving, okay, in bracket 3 minus 2 root of 2. Okay, then in another bracket, okay, 3 plus 2 root of 2. So we have 2 binomials multiplying. So we shouldn't be in a hurry. That's why every step on the way, think before you write. Okay, if you think before you write, your thoughts, that time that you used to think will be rewarded. And you will know the best, okay, way, okay, to deal with it. Therefore, you give us the ideal presentation. Ideal presentation will save you time and equally save you space. Okay, so let's see. I'm multiplying 2 binomials. Mr. Ackman said anytime I'm multiplying 2 binomials, I shouldn't be in a hurry to, okay, distribute or expand, okay, going using my normal way. Let me check whether it's a special situation. Okay, special situation will be a situation where you have same first terms, same second terms, either same signs or different signs. So here we have different signs between the terms. So, okay, it means we are dealing with a special situation. So this special situation where you have same first term, same second term, but difference in sign, we know if you expand, we are going to get, okay, difference of 2 squares. So this will give me my 3, my first term squared, okay, minus my second term, which is 2 root of 2 squared. All correct? Point well made, my professors.
Yes, please.
Great. Okay, so now this we know will give us 3 squared will give us 9. Minus, we know how to deal with this one. We are now matured. So I'll write it as 2 squared, which is for the root of 2 squared, which will give us what? 2. So in effect, we are going to get 9 minus what? 8. What we are going to write will be our final answer. So we know at this point that we can draw our conclusion, which we shouldn't fail to. So we have to always draw our conclusion. So I will go and write, because this is what an expression, it will always be there for your given expression is equal to your final answer, and that will give us 1 equally. Is that clear?
Yes, please.
Okay, great. Okay, and I've told you questions like this, especially if it's a theory question or even objective question. Objective question, I won't encourage you to do all this. Feed your calculator with this, then just press equal to, then write it. Okay, all right, take note. But if it's subjective, the point is you can use your calculator to check, okay, the validity or the correctness of what? Your answer. So please, okay, take note. Any questions at this point before you go and look at what? Our last, okay, question from this set. Any questions? My professors, are you there?
Yes, please.
Hey, today I think I have quite a number. Okay, so those of you who have joined, Okay, you've not been. Okay. Jacqueline, I've seen you. You are appearing twice here. What's the issue? Please save data if you can. Okay, disconnect one. Okay, if you don't want to, but you keep the money for me, I'll come for it. The money for the data, I'll come for it. Okay, all right. So I think I have quite a number here. Good, okay. Please make sure you are always regular. Sometimes I give you people the benefit of the doubt. Okay, it's possible maybe you have network issues and what have you. But please consciously make sure you join class. Your parents are paying for it. Okay, so even if they are not paying for it, you are acquiring knowledge and you have to really value that. Okay, so now what do we do? We are going to move on to our last question, okay, for this particular set. The rest, you can try your hands on there. Okay, so quickly, let's go and, so pick one. From C up to F, which one do you want us to go for? I know the obvious. Pick one. You have only one slot. We should go for
F.
F. I saw this coming. Okay, all right. Okay, so we'll look at F. I saw it coming anyway. Okay, so it was a good choice. All right, so now let's look at what? F. Okay, so F, what are we giving? Okay, 2 roots of 5. Okay, plus what? 3 roots of 3. In one bracket, multiplying, okay, 2 roots of 5. Okay, minus 3 roots of 5. So another bracket. Okay, so 2 binomials multiplying. I'm not in a hurry. I will always think before I write. Okay, so now so that I will save time, space, and equally use that time to go over my work. Oh, it's root 3. Thank you. Thank you. Okay, take it easy on me, okay? Consider my age. All right. Okay, so let me go and do the needful. This one, it wasn't intentional. You know, I've told you if it's intentional, I'll let you. Okay, so take note as well. Sometimes some of these petty mistakes that I also make, okay, I tell students that maybe it's a way of God trying to tell you that you should also be careful. Okay, if Mr. Ackman, this can happen to Mr. Ackman, it could happen to you as well. When you are writing, you have to also be careful. That is a situation where it is not intentional. Okay, so here, difference of two squares, we know same first terms, same second terms, difference of two squares always allowed. So will be the expanded result. So I'm going to get my first term here squared, my second term squared. So it will be 2 roots of what? 5, my first common term squared, then minus my second common term, which is what? 3 roots of 3 also squared. All correct? Okay,
Yes,
so
please.
you remember
Yes.
I told you in the previous question that that's the more reason why I did the last question in the previous set of questions. So I said we will need it. And you can see that we've encountered that situation. You remember? Okay, so you can see that we have a similar situation there. Can you see? So if you understood that one, then you should be able to continue from here. So you know how I structure my questions so that you will not be shortchanged at the point that I know definitely you are well equipped, okay, to deal with it. So you just dig into your toolbox, pick exactly what you need, okay, because you have all the tools. So now we know this one will give us 2 squared, which we know is 4. The root of 5 squared, which will give us what? 5. Okay, then minus, don't use your calculator to do this one straight away, please. So don't use your calculator to do this one squared, which will give you 20. No, do it. It will be 2 squared, then times root of 5 squared. But root of 5 squared is 5. So this will also give us 3 squared, which is 9, times root of 3 squared, which is what? 3. Remember I told you, if you mature, you can choose not to write it as in bracket the root of what? 5 squared. So this will give us what? 20. Okay, minus what? 20 minus
27.
27.
Okay, so our last step obviously will be when we find a difference. So we can draw our conclusion at that point. My professors, are you with me?
Yes, please.
Very good.
Yes.
Okay, so what do we have then into 2 root of 5 minus 3 root of 3, and we know this will be equal to minus 7. All correct? Okay, any questions? Any questions at this point before we move on to our next set of questions? Probably, maybe your classwork. So we are fine. Okay, so if that is the situation, then let's move on to, okay, your class assignment. Okay, so I'm going to pause here. Then I'll put it on the platform as well. Okay. Okay, so you are welcome back from the break. Okay, and before the break, you were given, okay, these questions as a classwork. So we are going to go through together. Okay, and as we go through together, so you can see marks assigned. So indirectly, we have a marking scheme. You use it to mark. If you have any questions, you ask. Okay, then after marking, you submit your marked work. I will go through as well. Okay, and you indicate the total marks. So in all, you can see that it will be total, the grand total will be 20. So you indicate it on top of what your first page. Today is really on top, not below your last page, your grand total. And it's supposed to be the total that you had over the 20. Don't just write your total. Write the denominator as well over what. Okay, quickly, let's go. So you extract what you are given. So a low hanging mark, B1. So everyone is supposed to get this mark. It's just you extracting. I'm encouraging you to extract. Okay, then after that, okay, remember the advice. We won't straight away go and multiply. We will not. Okay, straight away go and multiply. You can do that, but I want you to keep this advice. This one is the safe way to present your work. Okay, so in this case, we said, reduce all set that can be reduced. So first, before you multiply. So this set is not in its basic form. This is equally not in its basic form. So you go and reduce this. So in that case, I keep this. So my first step, if you start with implication, I'll come to the penalties, the honest, okay, and okay, effect what the penalties. So in this case, what do we have? Or apply the penalties. So what do we have? You keep your minus 2 root of 3. Keep this, okay, is this that you are going to work on? So that will give you, okay, root of what? 4 times 3. Okay, so then this one you work on, it will be root of the highest perfect square is 9. So 9 times 3. So that will give us, at this point, we are still not done, okay, simplifying or reducing this. So that gives you, here will be 5 into 2 root of 3. And this will be 3 times, if you reduce this, we get 3 root of 3. So now you come and remove, okay, this bracket here and this bracket, okay, as we move on. At the normal circumstance, okay, as you introduce the inner bracket here, mathematically, okay, the best way to present this is to, oops, okay, so is to put the whole of this one in, okay, in brackets, in the square bracket. I mean, change that outer bracket to a square bracket. So this would rather be a square bracket. That's the best way to go. Other than that, if it's an ordinary bracket, it should look bigger than this, as you saw it in the initial way. But I need to teach you the right way so that you will, okay, not desist from, okay, it. So that will be it. But that's not to say if you use the normal bracket, okay, the bigger one, okay, you'll be marked down. Only that is the right one. Okay, so now, okay, at this point, you can see, okay, if you remove this, what you are again dealing with the bracket, so you don't expand though, because you can see in the brackets, remember, I told you, check whether what you have in brackets, you have like terms to combine. And indeed, they are like terms. So by that, I'm going to get what? Okay, minus 6 root of 3. Then I come and multiply this, remove the final bracket here. This will be kept intact. So this will give me minus 2 times minus 6, that will give me 12. Then root of 3 times root of 3, which will give me root of 3 squared 3. Then plus what this. So you remove the final bracket and that becomes your final answer. So the mark allocation for this, B1, okay, as you simplify this and you simplify this one to M2, okay, as you come and, okay, do your final simplification here, M1, okay, take note. And with this one, okay, so that's what we have here. M2 for this particular step. Okay, and again, M1 for this step. Okay, M1 for this, then A2 for your final answer. So in all, you have a total marks of 10. So 3, 4, 5, 6, 7, 8, 9, 10. So 10 marks, no bonuses today. Okay, all right, so no freebies today. Okay, so what do we have? This one to the B, I'm going to explain. Then after that, you ask all your questions together. Okay, so B, this is what we have. Okay, and please, some of you, when you were moving from A to B, you didn't leave any line. I've told you, as you move from one sub question to another, you leave a line, at least a line, maximum 2 lines. But a line must be left anyway. Okay, don't put, it's only steps that you don't leave spaces between. Even when you are coming to conclude, don't leave any space. Okay, so this is, that's just by the way, this is extracted B half. Okay, where you realize that you are supposed to, you should see this one as what? A special binomial squared. Okay, and in that case, this will give you this squared, this one squared minus twice the product of this, then plus this one squared. That will give you M1.5. Okay, so at this point here, you square this, which will give you 2 squared, which is 4, the root of 3 squared, which is 3. Then minus, I'm going to multiply the whole of this. Then sets will multiply, which is the coefficient. So 2 times 2, so it will be minus, okay, here I'll keep the negative. So it will be 2 times 2, which is 4. 4 times 5, which is what? Okay, 20. So I'll get 20 root of what? 3 times 2, and that will be 6. Then plus this 1 square will give you 5 square, which is 25. Root of 2 squared, which will give us what? 2. So take note of that. Then at this point, come and remove the bracket here. Remove the bracket. This said it's already in its basic form, so you leave it intact. You don't touch it. Okay, then now your next step, you know, you can combine these two like terms. So if you combine that ends it with your steps. So you draw your conclusion. So here, so with this one, B half, A1.5, M1, sorry, M1.5, M1, M what? 1 here, sorry. So this is supposed to be M1 as well. So not A, it's not an answer mark. So M1 here as well, then your A1, which is your final answer. So now the last one, okay, obviously what do? We are going to, we see this as special binomials multiplying. So we use what we did today. Okay, you can see same first term, same second term. So we have to use, okay, the difference of 2 squares, but difference in signs. So it will mean if I expand, I'll get the first term here squared, my second common term, okay, squared minus. Okay, so this one will give you 7 squared, 49. Okay, root of 5 squared, which is 5, minus 2 squared, which is 4, the root of 3 squared, which is 3. Then you come and multiply this, which gives you this. Multiply this, which gives you this. So the next step, you are going to subtract. And if you subtract, you can draw your conclusion at that point. Take note. And that will give you, okay, the answer that we have there. Okay, so that will make it whatever we have here to be our final. Okay, so this one, B half, when you extract, M1.5, when you apply the principle of what difference of 2 squares, when you expand, then when you come and simplify this using what I said, M1, this will give you M1, your final answer A1. So 5 marks for this, 5 marks for this, no bonus marks. So please, if you have any question, and please take note, if you wrote this, when you are simplifying, anywhere that you are simplifying, assuming I'm using this as an example, so all the ones that you simplify, okay, especially, okay, this particular one, if you wrote this 5, okay, then into 5, let me write 5, root of 4 times 3. Without this root covering the whole of this, it will be M0 at that point, A0. Please take notes. So any of these 3, I think it's 2, that's if you write this way and you don't extend to cover. Okay, if the square root is covering only the 9 and not the 3, the meaning changes. So it's M0, A0. Take note, I had your attention drawn to that yesterday. So if you don't do the right term, then it means you have decided to be recalcitrant. Okay, so this one too, if it is not covering any of them, one of them, at least one of them, if it's not covering, it will be M0, A0. Take note of that. The meaning changes. Okay, you cannot write it not to cover that and come and deal with it as if it is covering. No, We only mark what you have there, not what is in your head. Please take note. All right, any questions? My professors, any questions? Okay, Prof. Pierrot, Peter.
Sir, please, question A.
Question
The
A.
When I wrote the question, that's the
Mhm.
B1.
This
Then
one, please
the
take
B1.
note. This is not the question. This is not the question. Okay, you can see that if I give you this, without this, will you be able to know what you are supposed to do?
Oh, please.
So this is part of the question, man, not the question in itself. So you extract this information provided, okay, and you use the information here to deal with it. So, okay, I understand you anyway. And
Okay.
you are not supposed to write simplify the following. Okay, maybe some of you write simplify and come and write solution. No. If you are writing all the questions, okay, the whole of this is the question. So if you are writing it, write everything before you come and write solution. I've told you this. Don't come and write, okay, you write this, okay, solution. Come and write B, solution. And if you write, you extract this information here before you come and write solution, then it means, this is what I mean. I think I saw this in your class test. Okay, and let me address it here. When the person was marking, I thought the person would do the needful. So I'm going to, so Prof. Peter, hold on, okay?
So how will you drink water?
Okay.
Okay, all right. Okay, so this is what I mean. So assuming maybe you wrote A, you extracted, then you came to write solution. Okay, and you came to write equal to, you wrote this one there. Okay, you can see that once you've written solution, it means the maths must be given here going. Whatever you have on top here is not part of your solution. So you cannot come and give your B1 there. I don't know if you get my point. Am I clear on that? Do you get my point?
Yes, sir.
Okay, so please, if you are part of those who do that from today, you know, I've told you, anytime you write a question, if you want to write the questions anyway, you write all the questions. After that, the first thing you write is solution, then followed by the question number. So if you don't number appropriately too, it will be M0, A0. You know the rule, the basic ones. Learn to protect our marks. Okay, in terms of numbering, I've said it, okay, times without number. Okay, then in terms of not leaving spaces between your steps, I've told you, not writing the questions, you know, all that. The first thing that you write is solution. I've told you all that. So by now, if you are still doing the old mistake, then it means we are not making progress. Okay, so that's just by the way, okay, and it's very important to take notes. Peter, continue.
Sir, please, when I extracted a question.
You said the question
Then, when I extracted it, I said when I extracted it.
Okay.
And then I came to step 4.
You move from here to step 4.
Yes.
No, obviously we know that you use your calculator. True or false?
False. Sir, please,
Okay.
I knew what I was.
You knew what you were doing.
Yes, I did. I did the rough work on a foolscap sheet.
No, then it means you are taking your marks away. If you are doing any rough work, remember I've told you, if the question demands that you need a rough work, you do your rough work here. I have decided to divide this page, okay, so that this will be one page, this will be, ordinarily there shouldn't be any line here. Okay, so that if I need a rough work, I do it here. You get my point? I've told you this, if there's any rough work, provide your rough work here. After that, what do? You cancel. You strike it out. However, you do that in such a way that it will still be readable. So you cancel it only once. So if you did it on a jotter or somewhere else, you would take your marks away because I wouldn't have evidence for me to give you your method marks. You get the point?
Yes, sir.
So please take note. All the tools I've given you, it's just a matter of you applying, okay, them as and when, or using them as and when. So if you move from here to here, okay, you know there is a missing gap. There is no evidence that you use your head. You did it mentally. So in that case, if I make the assumption that you use your calculator, you can't fault me. You
Yes,
get
sir.
my point?
Yes, sir.
Okay, very good. So in this case, obviously, okay, based on what you are learning, okay, don't be, so next time you do the right thing. So in that case, I will assume you use your calculator. Okay, so I'm going to give you only this mark. From here going, no, you won't get any marks there. Okay, maybe, okay, I'm going to be lenient. Okay, today being my day, so I will be lenient a little. Okay, all right, at least I didn't give bonuses. So let me be lenient, but please be careful. Okay, take notes
Yes.
of my leniency. So it means you lose only the marks here, but you get, okay, you said you move to step 4. So you move to this, is that not it?
Yes, sir.
So you get this mark, and the rest. But all the
Yes,
marks
sir.
here, you lose it because I can't give you marks for, okay, no evidence. But please,
Okay.
you shouldn't be as a rough work. Do it with your main work
Okay.
next time. Very good. Okay, any other?
Sir,
Okay, Prof. Nanekia, you put up your hand, please. You put up your hand for you to be called. Okay, Prof. Nanekia.
So this is a really funny question, but then
So should I start laughing?
but then the final answer, what if like you got like the 36, you didn't get that, but you got the 9 root 3?
Okay, so the final answer mark is supposed to be the same final answer. Remember, before you can get the final answer mark, what you have here should be exactly the same. You know, I've told you.
Okay.
Okay, so that one, okay, it should be exactly what you have there. Okay, all right. So no matter how, okay, juicy your reward that you give me, I will not, okay, lower that one. I can't do anything about it. Okay, all right. Okay, so Prof. Motorola, please change it to who is that?
sir, it's me, Prof. Isaac. Unfortunately,
Ike.
network connection has.
Okay, so no problem. So, okay, so you go. Go on.
Sir, the question B.
Okay.
Why is it that in the bracket is clearly negative? So shouldn't the signs everywhere be negative, but the last one was positive?
Yeah, it should be
As you was
positive. Okay, remember, we said this is your first term and your last terms will always be positive. It is your middle term that will depend on the sign that is here. Because at the normal circumstance, it's supposed to be, okay, plus in brackets minus 5 roots of 2 squared. But that will always give us positive, so we always ignore the negative. I don't know if you get my point. Or I should come again. Should I come again?
Sir, yes, please come again.
Okay, so this is it. Okay, I want to do everything possible to protect his mark. But as for this mark, it's gone. It's gone just like. Okay, so let's see. Okay, we have, I said if you have A, okay, let me put it down well. A plus B all squared. Okay, this will give us A squared, okay, minus 2AB plus B squared. That's the expansion, that's what it will give you. Then A minus B squared, okay, will give you A squared minus what, 2, oh, sorry, this is plus, forgive me, minus 2AB then plus B squared. I guess that's what somebody wanted to draw my attention to. Okay, so this is it. Always your first terms and your last terms will be positive. It is your middle term that the sign will depend on this. Okay, if this is positive, it will be positive. If this is negative, it will be negative. Just because, okay, so please, Piero, sorry, I want you to do this. Okay, you know A minus B, okay, all squared is the same as A minus B times A minus B. On your own, expand this, okay, we can do that here and see whether the last term here will be negative. This will give us A squared, okay, minus AB, okay, minus AB, then plus what? B squared. Is it minus B squared that you had at the last term? Prof. Ike, is it minus B squared that you had at the last term? Because this will now come and combine and give you the minus 2AB. So you end up getting A squared minus 2AB then plus B squared. Your first terms always, note, your first terms, your last term, which will be the squares of your terms, okay, must always be positive. It's a middle term that will, the sign will change, okay, based on, okay, what you have there. Okay, but the sign will take the same sign here for the middle term. Okay, I guess my point is well made. So if you change this one to negative M0, A0, take note. There is no way you can redeem yourself. Unless you brought the negative in brackets, which in that case, if you expand to, you still get a positive result because that will give you negative 5 squared, which is what? 25, and what? Root of 2 squared, which is 2. So if it is not in brackets and it's outside, you are doomed. Your last term is not negative. All correct.
Yes, sir.
Okay, great. Okay, so now I know you have learned, so you won't do this mistake. Okay, so that's why you need to ask questions so that we will dispel, okay, or deal with all issues. Okay. Any other? Can we move on?
Yes, please.
Okay, so we can move on. So please, if you are done marking, submit your marked work. Submit your marked work. If you are done marking, submit your marked work. Don't wait for me to tell you. Submit your marked work. You know the rule. So if you don't have any questions, concerns, and make sure you indicate the grand total after indicating the totals for each of them. Okay, just indicate the grand total on top of your first page. And please, if you solve in columns without ruling lines, when you are capturing, capture only this side as one page and come and capture the whole of this as another page. Otherwise, if you capture the whole of this as a page and there is no line there, I will consider whatever you have here as a rough word, so I will cancel it. Take note, I've been saying that some of you still are doing same. Okay, all right. So I think we are good to go. So we are going to continue. So let's look at what we are supposed to do next. So now we are going to deal with division. Okay, division, you can see, okay, a set over another set. Okay, and remember what we said in terms of what the rules for division. We said if you have A root of B divided by, okay, C root of D, then this will be equal to A, okay, root of B over C root of D. That's the basic meaning. So which in effect will give us what? The non, just as when we are multiplying, we'll multiply the non-radicals. So here when we are dividing, we'll divide the non-radicals as well. So it will be A over C. Then you keep your set. Okay, then come and divide. They are all radicals. So you put them dividing under the radical sign. So it will be B over D. Do you remember? Hello, my professor, do you remember yesterday?
Yes, yes.
Great, so that's the concept that we are going to use. However, this concept is best used in a special situation, which I will draw your attention to. Okay, so now let's go. Okay, so solution. We are going to look at solution to question 6. Okay, so question 6 here, we are asked to simplify what we have there. So what are we supposed to simplify? Root of 6, so giving root of 6 over, okay, root of 3. Okay, here they all have coefficients being 1. So it is like 1 over 1, which you know is 1. So you just come and divide your radicals. So that will give you 6 over 3. Keep your square root sign. And that will give you root of, okay, 6 over 3, you know, will give you 2. So this becomes your answer. You can't go further. So therefore, okay, root of 6 over, okay, root of 3, okay, will be equal to root of 2. As you mature, you know, we knew we could have ended here, so we could have drawn our conclusion there. Points well made, or I should come again. Is my point well made? I should come again. Okay, so you know from indices, okay, that if you have, okay, maybe A over B to a certain power, okay, the same as A to that power, your numerator over then your denominator to that same power. So in the same way, if I have, okay, indirectly root of A over B, I know that my root is affecting the numerator and is also affecting the denominator. So this is the same as root of A over root of B. So we went backward. Can you see that? Point well made now. So here, ordinarily, like I said, your A, okay, so this is A root of B, C root of D. A is 1, B is 6, C is 1, D is 3. So ordinarily it would have been 1 over 1, but we know it will be 1, so we don't write it. then root of your radicand, your numerator radicand over the denominator radicand. Okay, but since, okay, over 3, we know that is 2. So it will be root of 2, as simple as that. We'll do more anyway. So if your understanding is not better from the second one, then you draw my attention once again. So we have given root of 20 over what? Okay, root of 5. Okay, so this will be equal to, again, the coefficient 1, 1. So it will be, the coefficient will divide 1 over 1, I know will give me 1, so I won't write it. Then I write my square root, then my radicals will come and divide, okay, under the square root. So it's 20 over 5. Is that clear? Which gives us what? Root of what? 4. Okay, and in effect, we know root of 4 will give us 2. So therefore, okay, our root of what? 20 over the root of 5. I think I can write there. So let me clear it and go and write it because it will interfere with what I have there. I've gone too low. Okay, so now what do I write? This will be equal to my next page. Okay, so I was going to draw my conclusion. So otherwise, if you write equal to, you are now going to draw your conclusion. So take notes of that. My professors, are you following?
Yes, please.
Okay, so therefore, root of 20 over, okay, make sure it covers, over root of 5 will be equal to root of 4, which you know 4 is a perfect square, so it will give you 2. Okay, we are going to do one more, okay, of this one. So let's look at alternative situation, okay, for this particular one. Okay, so what are we giving? Root of 20 over root of 5. Okay, this will be equal to, and again, my advice, I've told you any set that you can reduce, if possible, reduce before you carry out any other operation. So we are going to go by that and we'll see. So that will give us what? Root of what? This can be reduced. So that gives us what? 4 times 5. Am I right? All over root of 5. All correct? It's my point
Yes,
well made.
please.
So we know that this will give us what? If you simplify the numerator, that gives you 2 root of 5 over root of 5. Am I right?
Yes, please.
Okay, so therefore, you know that this will cancel that. So to give you your answer that we are looking for, therefore, root of 20 over root of 5 is equal to what? 2. So you can see that that's why that advice is very useful. Okay, reduce all sets that can be reduced before you start, okay, applying your various, okay, operations. All correct. Okay, so
Yes.
on that note,
Yes,
okay, let's move on to what? B. Oh, okay, so I didn't create room for B. Okay, so let me squeeze the B here because my intention was to do only 2 questions, but the alternative, okay, as I think I should have done it here, but no issues. So let me, assuming this is my next page, that's why I've ruled a line there. So this is going to, other than that, if there's no line, this will be deemed as a rough work. So let me go for, okay, we've done, oh, this is rather B. Is that clear? So at this point, I'm equally doomed. So as I'm numbering, I'm watching out. Okay, so now I have C. Okay, we'll go for C. Okay, C. What do we have? Root of 46. Okay, over root of 2. Okay, which I'm going the usual route. But ordinarily, if this you can you reduce the set? If you can reduce, you reduce before you deal with it. Okay, so on that note, I'm going to get root of, okay, what do you call it? 46 over, sorry, over 2, which will give us root of what? That will give us root of what? 23, am I right? But root of 23 is in its basic form, so you end there. Okay, that will be it for our first set of what questions in terms of the division. Okay, we have a little more time, so let's go and look at the B. All correct? It's my point well made.
Yes, please.
Okay, so you can see that for the question 6, okay, the coefficients of the numerator set and the denominator 1 for each of them. Now you can see that we are looking at a situation where the coefficients, okay, are not what? 1. okay, both of them are not 1. Okay, maybe at least one of them, the coefficient is not 1. How then do you deal with this? So let's look at the next, okay, situation. So at this point, question number 7, okay, A. Okay, then what do we have? We've been given 12 root of what? 21 all over, okay, 3 root of what? 7. Remember the rule. Okay, the coefficient will divide. So I'm going to get 12 over 3. As you can cancel straight away. Then root of 21 on 7. All correct?
Yes, please.
Okay, so you know this you can reduce. So this you reduces to what? 4. Am I right? Okay, then, okay, 21 over 7 will give you what? 3. So now I could have drawn my conclusion there because there's a first example, you know, usually. Okay, I will go beyond. So therefore, 12 root of 21 over, okay, 3 root of 7 will be equal to 4 root of 3. All correct?
Yes, please.
Okay, very good. We are going to do, okay, 1 or 2 more. So let's go for B. Okay, B, what are we giving? Okay, 12 root of, okay, 40 over, okay, 4 root of 5. Okay, so this will be equal to, okay, this and this will divide. So I will do that straight away. I won't come and write it. Okay, so I will cancel and this will give me 3. Then I'll come and write root of my 40 over what? Over 5. Okay, so that will give me 3 root of 40, okay, over 5 will give us what? 8. Am I right?
Yes, yes.
But here, unfortunately, we can't end here, you know. Okay, the SURD is not in its basic form. The radicand contains a perfect square apart from 1. So you move on to reduce that. So that will give you 3. We are expert in reducing SURD. So that will give us 4 times 2. Okay, which will give us 3 into 2 root of 2. Okay, so in effect, we are going to get 6 root of 2. So that will be your final result. So at that point, I will draw my conclusion. All correct?
Yes, please.
Okay,
Yes,
all right.
please.
And please make sure when you are writing your numerator over the denominator, make sure the square root covers both the numerator and the denominator. Other than that, if it covers only the numerator, the meaning changes. So take note. Always extend it to cover the denominator as well, if that's what you want to imply. Okay, so we get over 4 root of 5 will be equal to 6, okay, root of 2. Safa.
Yes, please.
Very good. Any questions at this point?
No, please.
No, please. So you are fine. Okay, so I guess, okay, so Prof. Agnes.
So what if let's say 12 out of 4 square root 40 out of 5. What if 12 cannot divide 4?
Okay, don't worry. We'll come to that. You know how I teach. Okay, so we'll come to that. So here, this is it. Okay, Rosemond, before you come in, maybe after saying what I'm saying, it's possible maybe you, this is it. This rule for division, you usually use it when you realize that the radicand in the denominator, okay, is a factor of the radicand in the numerator. Then that would be the perfect way to go. Should I come again?
Yes, please.
Okay, you use this approach. Okay, and even you can see that the previous approach, I mean, question the same. Let me go back and start from there. Okay, all right, the questions are here. You use this approach where you write it as what? Your coefficient dividing the root of your radicand dividing. You use that when you realize that your denominator radicand is a factor of your numerator radicand. So obviously 3 is a factor of 6. Am I right?
Yes, please.
5 is a factor of 20. 2 is a factor of 6. 3 is a factor of 27. 8 is a factor of 24. So with this, we can use, okay, that approach. Okay, let's move on to the second set of questions too, the 7. Okay, 3 is a factor of 21, 5 is a factor of 40, 3 is a factor of 18, okay, 15 is a factor of 60. Okay, so in that situation, it means we can use that. Is my point well made?
Yes, please.
Okay, however, okay, this will move us into another realm. Okay, so it is part of what the situation that you are supposed to handle as your assignment. So this is what is going to happen, and this will be your homework. Okay, when the last one will move us into another realm. Okay, so Prof. Rosemond.
Please, the 4th point, please, can you come again?
Okay, so I'll look at it. Let me go back. Oops, here. Is it this one? The A.
Yes, please.
Okay, so what exactly?
Please, the 4th point.
4th point.
Sorry, the B.
The V, this one. Okay, so you know this must be reduced, is that not it?
Yes, please.
Okay, so when you are reducing it to be, this will be 4 times 2, the highest perfect square you can get from 8 factor, highest perfect square factor, and that will be what you have here. Okay, so I've told you I'm equally going to, so this must be extended to cover there. So you write that as 4 times root of 2, 4 times 2. But you know that what you have here, if you reduce, finally will give you 2 root of 2. Do you agree? But the 3 is there. You've done this, so you've gone beyond this.
Yes, please.
Okay, so this, okay, will now give you 3 times 2, which is 6, then root of 2. So I use that to draw my conclusion. Safa.
Yes, please. Thank you.
Great. You are welcome, my professor. All right, okay, so this will be it for, okay, today. Targets reached. Okay, you contributed and you made the class, okay, interesting. Okay, you ask questions, and usually when you do that, okay, you put smiles on my face. Okay, so please make sure, okay, you continue asking questions. Those of you who are very passive, okay, please, no matter how intelligent you are, you will have 1 or 2 questions to ask. Okay, if you are very intelligent, then we expect that you ask questions and that question will, okay, bring out that fact that you are intelligent. So you should ask questions. You will ask intelligent questions. So everyone should ask what questions going forward. Okay, I'm always here because of you. Thank you very much once again. God bless us all.
Amen.
Okay.